According to the Central Statistics Office, CSO, there were 65,909 babies born in Ireland in 2015. Of these, 32,290 were girls. In the first part of the question, we must find how many boys were born in Ireland in 2015. The key observation here is that together, the boy babies and the girl babies will combine to give us the total number of babies. Another way to view this is that the boy babies will be equal to the total babies minus the girl babies. The total number of babies is 65,909. The number of girl babies was 32,290. To find the number of boy babies, we must subtract these numbers away. So our answer here is that there were 33,619 boy babies. In the next part of the question, we must find the probability that a baby picked at random from those born in Ireland in 2015 is a boy. And we must give our answer correct to 2 decimal places. A useful fact to keep in mind is the following. Assuming equally likely outcomes, the probability of an event is the number of desirable outcomes divided by the total number of outcomes. We're asked for the probability of picking a boy baby. So in this context, the number of desirable outcomes refers to the number of boy babies. The total number of outcomes refers to the total number of babies. So to find our probability, all we have to do is divide these 2 numbers. Rounded to 2 decimal places, the probability of selecting a boy baby is 0.51. Eight babies were born in Limerick's maternity hospital on the 1st of May 2015. Use your answer in part A, II, to find the probability that the first 3 babies born were boys. Give your answer correct to 4 decimal places. It's difficult to reason about all 3 babies at the same time, so let's break things down one by one. The first baby, the second baby, and the third baby. We need the first 3 babies all to be boys. The only way this can happen is if the first baby is a boy, and the second baby is a boy, and the third baby is a boy. In probability, when we see the word "and", it indicates that we should multiply the individual conditional probabilities. So once we find the probability of each of our individual events, all we have to do is multiply them all together. Well, in part A, II, we found that the probability that a randomly selected baby is a boy is 0.51. so the probability that the first baby is a boy is 0.51. Similarly, the probability that the second baby is a boy and the probability that the third baby is a boy are both 0.51 as well. Now that we have the individual probabilities, we must multiply them together. Rounded to 4 decimal places, the probability that the first 3 babies born were boys is 0.1327. The next part of the question reads, find the probability that the third birth was the first girl born in the hospital that day. Give your answer correct to 4 decimal places. Again, a good strategy here is to break things up baby by baby. We want the third birth to be the first girl. This means that the first baby is not a girl, the second baby is not a girl, and the third baby is a girl. In other words, we need the first baby to be a boy, and the second baby to be a boy, and the third baby to be a girl. Similar to above, when we see the word "and", it indicates that we should multiply together the individual probabilities. We know that the probability of randomly selected baby is a boy is 0.51. So, the probability the first baby is a boy is 0.51, and the probability the second baby is a boy is 0.51 also. The probability that the third baby is a girl is a little less clear, so we'll have to do some work to figure this out. The following probability fact will help us here. If you consider all the possibilities, the probabilities must add up to 100%, or 1 in decimal form. In this question, we've been using decimal form for our probabilities. Using this fact, we know that the probability of getting a boy baby and the probability of getting a girl baby must combine to add up to 1. Another way to think of this is that the probability of a girl baby will be 1 minus the probability of a boy baby. And we know the probability of a boy baby. It's 0.51. And when we do the calculation, 1 minus 0.51, we get 0.49. So this is our probability of getting a girl baby. We've now written in all our individual probabilities. From here, all we have to do is multiply them together. Rounded to 4 decimal places, our final answer here is 0.1274. The table below shows the probability of being born on a particular day of the week. Complete the table. We are provided with the probabilities of being born on a Monday, Wednesday, Thursday, Friday, Saturday, or Sunday. The only thing that's missing here is the probability of being born on a Tuesday. To make our lives a bit easier down the road, I'm going to label this unknown value with x. Well, the key fact to remember here is that if you consider all the possibilities, the probabilities must add up to 100%, or they must add up to 1 if you're working in decimal form. In our table, we've listed all 7 days of the week, so we are covering all the possibilities for the day that you could be born. This means that if we add up all the probabilities, we must get 1. From here, we can solve for x. A good first step would be to do some simplification on the left-hand side by adding up all those numbers. So we know that x plus 0.84 is equal to 1. To find x, all we have to do is remove this plus 0.84. This represents addition, and the inverse of addition is subtraction. So to remove it, we will subtract 0.84 from both sides. So we found that the probability of being born on a Tuesday is 0.16. Part II. In a particular week, 1,300 babies were born. Find the number of babies expected to be born on the Tuesday of that week. The key to solving this question is the following observation. The expected Tuesday babies is equal to the total babies born in the week multiplied by the probability an individual baby is born on a Tuesday. In this question, we're told that 1,300 babies were born in the week. In the previous part of the question, we found that there was a 0.16 probability of being born on a Tuesday. To get our answer, we multiply these numbers together. So our final answer is that the expected number of Tuesday babies is 208.